All right. Hello, one. Hello, all. Welcome back to the stream. I hope you're having a wonderful day. Welcome back to my channel. Today is Thursday, February 27th, 2025. And we are going to be back doing none other than teaching ourselves how to program. Welcome, you guys. I hope you're having a wonderful day so far. Today is going to be a fun one. We're going to hopefully be learning some stuff and yeah, so it should be a fun one. I'm excited for it. Let's go ahead and throw on the do not disturb and let's get this party going. Hello, Mahan. Welcome back. Welcome back to the stream. Hope you guys are having a wonderful day so far. Let's go ahead and let some people roll up on in here. If you guys aren't familiar, you can join the Discord link down below in the description. All right. Starting with some reading in Python, and then all right. Hello, everybody. Welcome back. Welcome back. Welcome into the stream on this wonderful Thursday. I hope you're having a wonderful day. Mahan is in here. ESCM9SB is in here. How's it going? Wing Hong, welcome back. Tim's getting trumped every night here. Welcome back, everybody. I hope you're having a wonderful day so far. For those of you that do not know, we are multi-streaming live to Twitch right now. I don't think I have that link in the description again. Oh, shoot. I also wanted to go like this. Let's see if we can try this as well. I wanted to go like this. Let's go here, here, pop out. Let's see. Give me 1 second. One second, you guys. I wanted to just make sure. I want to try to get. Oh, here we go. That's it right there. So I got it. Okay, now let me go here. 1 second. This is going to be cool, I think. Give me 1 second. Okay, let me take this. Put in this. Okay. Show. Oh, here we go. Now I'm going to move this here and down. Can you guys see that? All right, now let me see if I can get rid of the let me see if I can just get rid of the fixed height here. Increase the height to there we go. There we go. Is that good? Can you guys see how's that look? Is it kind of it's kind of glitched, no? Let me see if I can fix that. It wants 600. All right, that's fine. We'll leave that there. How do you guys like that? You guys like having the chat here as well on the screen? So you guys can see. What do you guys think about that? You guys want a different location? Does it need to be bigger? Can you not read it? Let me know. Probably needs to be a little bit bigger, I would say. Like such. Let me put that below here. Slide that in. Get that, I guess I could just actually lower the width, huh? Let's make this. Why is it all like glitched? Hold on. Sorry guys, I want to try to get the chat on here for us so we can have everybody see it, but I want to get it so it's not. Oh, there we go. It just needed to update. So I need. There we go. All right, I like that. How does that look? I think that looks nice. Right there on the bottom. Let me take a peek on the actual stream here. Ooh, go back. Okay, I like that. That looks nice. That looks nice. Haha. Sweet. That worked. Cool. All right, we got this. We got a chat going on here live, so you guys can read chat as we're going, and like see your messages pop up. I think is fun. As it gives you guys some incentive to chat if you're actually seeing your messages pop up live onto the chat itself. But thank you guys so much for joining me here. You guys are super awesome. Today is February the 27th, Thursday, 2025. We're going to be starting off with some reading in chapter 10 of the Data Structures and Algorithms in Python book that we've been reading. We're on page 400 and... We read about the cyclic shift. Collisions. We're right here on 415. Right? So, that being said... we have a couple of chapters here. Let's try to get to page... I don't know. Let's just start, I guess. Okay, we're gonna start with some reading in DSA and Python. Then we'll try to do a Leet code problem, and then we will work on the small business manager. How about? And then we'll maybe try to get some HTML going, a little bit of a base HTML, boilerplate going for the small business manager to potentially make it have a front end to it. All right. The standard mechanism for computing hash codes in Python is a built-in function. Okay, so we're on Python, hash codes in Python, 10.2. The standard mechanisms for computing hash codes in Python is a built-in function with the signature hash x that returns an integer. Hash x that returns an integer that serves as the hash code for object x. However, only immutable data types are deemed hashable in Python. This restriction is meant to ensure that a particular object hash code remains constant during that object's lifespan, right? We don't want to have a hash code on an object that is a list because that list might have, appends or removes from it and or pops from it, and it could have then be given, technically have a different hash code associated with it, so it needs to be immutable. A problem could occur. This is an important property for an object's use as a key in a hash table. A problem could occur if a key were inserted into the hash table yet a later search were performed. If a key were inserted into a hash table, yet a later search were performed for that key based on a different hash code than that which it had when inserted, the wrong bucket would be searched. Among Python's built-in data types, the immutable int, float, stir, tuple, and frozen set classes produce robust hash codes via the hash function, using techniques similar to those discussed earlier in the section, like the cyclic shift hash codes or the polynomial hash codes. Right, those were some good examples they gave. Hash codes for character strings are well crafted based on a technique similar to Python polynomial hash codes, except using exclusive OR computations rather than additions. If we repeat the experiment described in table 10.1 using Python's built-in hash codes, we find that only 8 strings out of the set of more than 230,000 collide with one another. Hash codes for tuples are computed with a similar technique based upon a combination of the hash codes of the individual elements of the tuple. Hash codes for tuples are computed with a similar technique based on the combination of the hash codes of the individual elements of the tuple. When hashing a frozen set, the order of the elements should be irrelevant, and so a natural option is to compute the exclusive OR of the individual hash code without any shifting. If hash x is called for an instance of x of a mutable type, such as a list, a type error is raised. Okay. Instances of user-defined classes are treated as unhashable by default, with a type error raised by the hash function. However, a function that computes hash codes can be implemented in the form of a special method named underhash within a class. Okay, so if you have your own custom class in Python, you can create a hash method basically to allow it. So within the class, the returned hash code should reflect the immutable attributes of an instance. It is common to return a hash code that is itself based on the computed hash of the combination of such attributes. For example, a color class that maintains 3 numeric red, green, and blue components that might be implemented as the method below. So if you have a color class that maintains 3 numeric red, green, and blue components, might implement the method as, for its hash, return hash of self.red, green, and blue tuple, right? So you're going to hash the entire tuple of these characters. An important rule to obey is that if a class defines equivalence through the dunder EQ, or dunder equivalence, then an implementation of the underhash must be consistent. That if x is equal to y, then hash x is also equal to hash y. So if you hash something with a different alias basically, but the values are the same, you should receive the same hash value back for that. This is important because if 2 instances are considered to be equivalent and one is used as a key in a hash table, a search for the second instance would result in the discovery of the first. It is therefore important that a hash code for the second match the hash code of the first so that the proper bucket is examined. This rule extends to any well-defined comparisons between objects of different classes. For example, since Python treats the expression 5 is equal to 5.0, so the integer 5 is equal to 5.0 as true, it ensures that hash 5 and hash 5.0 are the same hash value. Okay, that makes a lot of sense. Hey Ryan, how's it going? Welcome in. How's it going? How's the course been treating you? Hopefully you're moving along. Did you start up the Python one as you got to the Python week? Are you kind of like branching out of the CS50X course now that you got to the Python week and taking the Python course? You mentioned that you were doing that one. All right. Compression functions. The hash code for a key K will typically not be suitable for immediate use with a bucket array. The hash code for a key K will typically not be suitable for immediate use with a bucket array because the integer hash code may be negative. Whoa, what's going on? Compression functions. The hash code for a key K, will typically not be suited for immediate use with a bucket array because the integer hash code may be negative or may exceed the capacity of the bucket array. So remember, there's 2 parts to the actual hashing of an object, which is obtaining a hash value and compressing that value down to a range of between 0 and 1, right? No, mapping it down to a range of 0 to the n, 0 to n minus 1. Sorry. Thus, once we have determined an integer hash code for a key object k, there's still the issue of mapping that integer into the range of 0 to n minus 1. This computation, known as a compression function, is the second action performed as part of an overall hash function. A good compression function is one that minimizes the number of collisions for a given set of distinct hash codes. The division method. A simple compression function is the division method, which maps an integer I to n, so I mod n, I modulo n, where n, the size of the bucket array, is a fixed positive integer. Additionally, if we take n to be a prime number, then this compression function helps spread out the distribution of hashed values. Indeed, if n is not prime, then there is greater risk that the patterns in the distribution of hash codes will be repeated in the distribution of hash values, thereby causing collisions. For example, if we inserted keys with the hash codes of 0, 205, 210, 215, 220, all the way to 600 in a bucket size of 100, then each hash code will collide with 3 others, right? Just because you have to have 3 values per bucket to make it even, basically. If we use a bucket array size of 101, then there will be no collisions. Oh, what? For example, if we inserted keys with hash codes there in a bucket array size of 100, then each hash code will collide with 3 others. But if we use a bucket rate of size 101, then there will be no collisions. Why is there no collisions? If a hash function is chosen well, it should ensure that the probability of 2 different keys getting hashed to the same bucket is 1 over n. Choosing n to be a prime number is not always enough, however, for if there is a repeated pattern of hash codes of the form of pn plus q, p times n plus q, for several different p's, then there still be collisions. What is this saying? Can you... Oh, hold on. Can you please break down this in more simple terms with an example? I don't understand why 101 buckets causes no collisions compared to 100 buckets. Sure, let's break down this step by step. What's the division method? The division method takes a number I, which is usually the hash code of a key, and maps it into a bucket by computing I mod n, where n is the number of buckets. The modulus operator, percent or mod, gives the remainder when I is divided by big N. Yep. This remainder determines the bucket where I is placed. Why does choosing big N matter? If big N is poorly chosen, certain patterns in the numbers can cause collisions, meaning multiple numbers get assigned to the same bucket. In this example, n is equal to 100 non-prime. Okay, so it's just a non-prime value, meaning that it's divisible by itself, 1, and some other values. A prime is only divisible by itself and 1. So we know that 100 obviously is divisible by 1, by 2, by 5, by 10, by whatever after that. So suppose we insert keys with the hash code. Okay, so if you do this, I get you. Because you have a non-prime n value, you're more likely to have collisions because it can be divided and have multiple values, multiple multiples of, that would create the bucket size, basically. So the modulus using a non-prime, data set is kind of difficult to do, or difficult for integers, right? David, you're popping in the streams like every single day, so you're giving yourself some credit. I think you should give yourself some credit, at least popping in here and at least hanging out for a little bit, and taking in, a little bit of the reading or the Leet code or the project or whatever is, good enough, is definitely good, a good day's work of studying and stuff. So, give yourself some credit just by popping in here day after day. You've been able to probably pick up on some things and become familiar. And, it's definitely, it's a group effort here. I appreciate you being here, David. You're awesome. Hello, everybody else. Let me know what you guys are working on, what you're studying. Chat it up in here. Let's get some chats rolling. We had a lot of chats yesterday. Everybody was really, really chatty. And it was super fun answering everybody's questions and talking to everybody and, just discussing, computer science and everything. But thanks so much for being here, you guys. Consider throwing a thumbs up on the stream if you're here and, enjoy, hanging out with me. I really, really appreciate everybody jumping in and being so kind and willing to hang out. So when you have 101, right, a prime number, right, you're not impacted by repeating value. So 200 mod 101 equals 98, 205 mod 3 to 10. So you don't get any collisions with this one because n is prime, right? Because you would either have to have a value of 1 or 101 for a hash value to get a collision, and that wouldn't happen because you're mapping to it, right, into those values typically. Hey, Jacob Allen, welcome back in. It's awesome to hear from you. What's going on? What you've been studying today since the last stream? Have you been working on anything or just been chilling? No worries. Let's work on something here. We're just reading some DSA in Python. You guys want access to the book and my notes? Everything can be found in my Discord down below, free of charge. I provide you PDF copies of the book, and it's a great book. We're on page 438, reading about hash codes. And then, the two steps to creating a hash table where you would have to, create a hash code using some sort of function, and then also compressing that value down into a value in the range of the bucket size of the hash table, which is typically, right, the size of the data set itself, one for each, hopefully one data set for each bucket, or one data point. Got you. Okay, so let's talk about, this is hash functions, so we need to talk about here compression functions. So compression, the second part of creating a hash or bucketizing hash values, or creating a hash table where you compress arbitrary hash values created during the the creation of hash codes in hash codes. Returns a value corresponding to a bucket to index the element into our hash table. In the range of 1 to n minus 1, 0 to n minus 1. Right. Let's throw this guy in the Jibbity and see what he likes, if he likes our definition here. Yes, exactly. The compression function, the second step in creating a hash table, ensures that the arbitrary hash values, which could be large or spread out, are mapped into a fixed range that fits within the available buckets of our hash table. Breaking it down, hash codes create the compression function. The hash code is then compressed into a valid bucket between index 0 and n minus 1, where n is the number of buckets. This is done by using a compression function like the division method, I mod n. This ensures that all elements, right. Okay, so let's take this, I like this definition for compression function, this example. So let's take this guy here, and let's put it, I like this, the second step, this more, it's pretty much the same, but it's a little bit cleaner. The second step in creating a hash table ensures the arbitrary hash value is large, right? Returns a value, perfect. And then we'll say, we'll go here and do examples. Number one is going to be the division method, right? Which is where using the mod or operator to find the remainder of I hash code modulo n. Alright, so hash code modulo n, big N. Right, and then we'll say if n is a non-prime value, this creates an increased chance for collisions as more values are multiples of n. If n is a prime value, this reduces the chance of collisions to almost or zero, almost to zero or almost zero. In some cases. Okay, so like prime value like 100, no 101, 100 non-prime. And it's a prime value like 101. Let's see if it likes this for the division method. Here is my def of the division method. That's a solid definition. It clearly explains how the division method works and why choosing a prime number for big N is important for reducing collisions. Here's a slight refinement for clarity and precision. The compression function that uses the modulus operator to map a hash code into a valid bucket index, bucket hash code modulo n, if n is a non-prime value, e.g. 100, so we'll need to do that, e.g. 100, collisions are more likely to happen because many hash codes will share a common factor. Sorry, not multiples, factors I meant. Those are more factors of it. The distributed hash will spread out. Prime numbers reduce the chance of patterns leading to repeated bucket assignments, minimizing collisions. Almost zero or zero in some cases. Or even zero in some cases. All right, let's catch up on a couple of chats here. Hall Minotaur says, hey, do you think talking it out makes you learn better? Oh, definitely, 100%. It's really easy to get lost in your own head when you're reading, especially through this dense material. I get lost when I'm reading it out loud even. So just think about if you're trying to process it all in your head, alone, it's definitely going to get foggy up there. Now, if you're able to do that, props to you. You're awesome. But by like talking it aloud, I am hearing myself back. I am talking my way through my thinking. I am explaining myself, interacting with you guys. I have to listen back when I edit the videos and my streams and I hear those topics again and again. So all of that together just really compounds the learning. And yes, talking it through, I think really, really helps. They say if you want to become a better reader, to read aloud, I think is what they always told us, like as kids, is because that even if you're like, it'll even translate to reading faster in your head, just because you have, I don't know, reading aloud is like a really, it's like a proven thing back from elementary school. That's what they always told you. I don't know. Hey, Chili Millie. Hi, I'm studying for AMC 10. What is AMC 10, Chili Millie? Thanks for coming in and joining me here. What's going on with you? That's a new name I haven't read, I don't think, in a while. I'm not sure. So appreciate you for joining me here. Let me know more about yourself. You're awesome. Thanks for jumping in here and leaving me a message. We learning how to build hash maps from scratch. Yeah, so we're just reading the DSA book. We're over like 3/4 of the way through here, or almost to 3/4 of the way through. So we've got a lot of material that we've read through and really studied and ground away here. So yeah, we got to keep going. I want to finish this book. This is a, we do this on the off days. We don't do like the courses and stuff to keep up with just to break up the streams and everything. This is beyond your web developer. Don't be scared of low-level languages. Yeah, this book really gets dense, into compression functions and different ones you can do. The modulo one doesn't seem too bad. That one seems fairly straightforward for certain circumstances, right? But yeah, we're getting some practice with this here, and then into some Leet code that we've been slowly chipping away at using this knowledge and stuff. If you have the book, I might give it a crack in Node.js, though I'm not bad. I'm bad at Python. Yeah, it's in just in the Discord. Yeah, Big O it's like everywhere. It's everything, right? It's everywhere. It's overarching I. I did about 6% of Colt Steele's JavaScript algorithms and data structures master class in JavaScript, which was pretty good. Nice. Honestly, I forgot most of it though. Off the top of my head, I don't do this sort of stuff in my web dev job. Yeah, it's easy when you're in your job, when you're focused on actually building products and making money for, the economy and for the, it's hard to, keep up with some of those concepts that you learned in the past. I definitely feel that with my chemistry. If your framework was this guy's study habits, you'd exit your escape hatch and get to. Yeah, I can't do this after working a full-time job programming. Yeah, I can study for an hour or two tops after work. Yeah, it's difficult. Yeah, it would be difficult to do software all day and then do software even more after. Like, yeah, it's definitely easier that I'm able to break up into a different subject completely. You guys are awesome. Yeah, we're back at it. Let's go. How you doing? You reading that book, Carlos? AMC 10 math test in US. I also code Python and building machine learning model for wildfire prediction. That's really cool. Nice, dude. All right, let's keep on reading here. Thank you guys so much for joining me. Let me know what you guys are working, what you're studying on in the side or on the background. You can really use this stream as like an accountability holder So where, I stream every single day, I've gotten into this habit. I'm really good at kind of holding myself accountable to do things. And so if you're also wanting to have a similar, study habits and way of thinking and mindset, then you could easily just, mimic the sessions here, and just, if you see me streaming, you also come on for at least, 30 minutes to an hour, and just studying your own subject. It doesn't have to be very long. I know I go for quite a while, but you can literally do only as little as 30 minutes, and get quite a bit done if you're really focused. And don't do chats like me. Like, right, I'm chatting. Thank you, all minutes, sir. Yeah, as I'm really trying to, compound this material, I found that daily study, trying to learn this stuff, is honestly kind of, uh, I would say, key. Like, in order to really compound all that, so much material, in order to keep this compounding and keep it going, I have to do it every day, because if I take a few days off, or if I start to let it fade, it really becomes kind of like a waste of time at that point, because why did I even learn it in the first place, or spend the time and the investment learning it? I don't want to let it fade. I want to keep and retain the knowledge for time and time again. Similar to like my college experiences, now that I'm out in the field and working as a formulation chemist for a biotech company, I don't I'm starting to lose all of that more raw, deep level understanding of, biology and chemistry, that was, more dedicated to like the studying and the textbooks and stuff. Where now I'm building, complex products, using some of my knowledge from back then, but all of that more niche, equations and math and everything in chemistry, I it's starting to really fade. And I really want to maybe do like a refresher, but I don't want to let that happen for this. I want to keep compounding this daily. Awesome, Eclipse. Glad that we could be on the same page here. If you guys like the study habits and like the stream, feel free to throw a thumbs up on the stream, and it really, really helps. You guys are awesome. Truly, you guys don't really. I look at those thumbs up, and it really, it does, help to actually boost the stream, and YouTube keeps promoting us. And honestly, on a personal level too, it really just, provides a little bit of a, yeah, nice. And mainly keeping the stream growing here and getting our community growing is awesome, because we love talking to new people and getting new perspectives on things. So now we're going to talk about the MAD method. So the MAD method, to the MAD method for generating or compressing hash codes. So a more sophisticated compression function which helps eliminate repeated patterns in a set of integers is the multiply, add, and divide, or MAD method. This method maps an integer I um, to this function here, where you go inside of the parentheses here, you go some coefficient times the some coefficient times the hash code, plus some other, arbitrary value b, modulo by p mod by n, where n is the size of the bucket array, right? Like normal. So you get the remainder of the bucket array, and p is a prime number larger than n. So you purposefully, similar to the division method, right? You purposefully choose a prime number and modulo that, and then modulo even again by n to have that value between. Oh, got you. So it has to be larger than n though. And a and b are integers chosen at random from the interval 0 to p minus 1, where with a being greater than 0. This compression function is chosen in order to eliminate repeated patterns in the set of hash codes and get us closer to having a good hash function, that is, one such that the probability of any two keys colliding is 1 divided by n. This good behavior could be the same as we would have if the keys were thrown into a uniformly at random. So it's just kind of trying to mimic like a randomization, basically, in just by kind of creating, random values between some range that makes this property, be true. So you get values between 0 and at the end of it, and it, yeah, for that's, I guess. So we'll say the multiply, add, and divide method mimics a random bucketization, maybe? I'm not sure. We'll get some clarity from the Almighty. Mimics a random bucketization using the following here A times I, or times some hash code, plus B modulo P modulo N, right? So these are the properties for this. P prime number greater than N A is a random integer between 0 and P minus 1, and A is greater than 0, and then B, right, is a random why did I put E's there? Integer between 0 and P minus 1, right? Good patterns gives close every good probability of 2 gigabytes. This has a probability of collisions, key collisions of 1 over big N. Right? Cool. All right. Let's get caught up on some chats here. I should get back into my design patterns book. Yeah, definitely. If you think you're, losing that material, probably consider jumping back into it. It's very prevalent, honestly, in what they're asking today for interviews and stuff. But honestly, just for knowledge and just helping you kind of also not even for interview purposes, but just the dense material also just really helps to learn as well. Being able to translate this English verbiage in a book into our own code and our own language is really helpful in actually understanding this and breaking it down and learning how to learn, really. Not me justifying days off with I'm going to let it sink in. I feel like whenever I build these kinds of things, I need to step it through in a debugger line by line as I'm building it and scribble notes in my notebook as I go to visualize everything. Kind of my strategy for doing Leet code too, like when traversing nodes in a graph. Yeah, I need to get better at using the debugger for sure. I definitely don't take advantage of that as much as I should, which is not good. Okay, let's read for we got 15 more minutes of reading here, and then we'll jump into a Leet code problem, then we'll work on the small business manager. How about, guys? Thanks so much for being here. We've been streaming for 45 minutes almost so far. So it's going great so far. We're learning about hash functions, and more specifically the compression functions, the part 2 of creating a hash table, by compressing the function into an arrange appropriate to bucketize the elements between a value of 0 and n minus 1. Or big N minus 1, right? Okay. So collision handling schemes. The main idea of a hash table is to take a bucket array A and a hash function H and use them to implement a map by storing each item key value into a bucket, right? Array A index H sub k, right? Just like in a dictionary, basically. This simple idea is challenged, however, when we have two distinct keys, k1 and k2, such that h of k1 is equal to h of k2. Right? This is when a collision happens. The existence of such collisions prevents us from simply inserting a new item, key value directly into the bucket array index h of k. It also complicates our procedure for performing insertion, search, and deletion operations, right? You have to detect if there's a repeated one, right? A simple separate chaining. So this is kind of like that example, literally from CS50X, right? At CS50X, we had that problem where we had a hash function, and then we had a linked list that chained those bucket items together if you had collisions. So a simple and efficient way for dealing with collisions is to have a bucket, A at index j, store its own secondary container for holding items key values such that the hash k is equal to j. A natural choice for the secondary container is a small map instance implemented using a list as described in section 10.5.1.5. This collision resolution is known as a separate chaining. Right, so let's look up, we'll do, we'll go here and go collisions. I think I don't have that already, yeah. We'll say here, we'll go separate chaining. So this figure is a hash table of size 13, 0 through 12, storing 10 items with integer keys with collisions resolved by separate chaining. The compression function is h of k equals to k modulo 13. So you just use the division method. For simplicity, we do not show the associated values with the keys. In the worst case, operations on the individual bucket take a time proportional to the size of the bucket, assuming that we have a good hash function to index the n items of our map in a bucket array of capacity of large n. The expected size of the bucket of our dataset divided by the bucket size, therefore, is given. If given a good hash function, the core map operations run in O of the ceiling of our dataset divided by our amount of buckets. The ratio, what is this? This is not lambda, no? Is this lambda? Anyone remember? Yes, lambda. Okay. Value of mathematics linear algebra. Okay. Called the load factor of the hash table. Should be bounded by a small constant, therefore preferably below 1. As long as lambda is O of 1, the core operations of the hash table run in O of 1 expected time. Alright, that made no sense. What? Can you please break down this? Understanding bucket-based hashing. The hash table consists of an array called a bucket array, right? Where each entry bucket can store multiple key value pairs. A hash function determines which bucket the item goes into. If two different keys map to the same bucket, they are stored together. This is called a collision. the worst case bucket size. In the worst case, all n items, all of our data, could end up in a single bucket, therefore making operations like searching for an item take O of n time. However, this happens only if the hash function is bad. It doesn't distribute keys well. Expected bucket size with a good hash function. If the hash function is good, items are distributed evenly across all of the buckets. Each bucket, on average, will contain about, n divided by the amount of buckets on average, right? The amount of data we have divided by the amount of buckets. So it gives you the amount of data per bucket. This means that for looking for an item with a single bucket, we'll take O of the items per bucket, taking, which makes sense, right? Because if we're evenly distributing with a good hash function across all of our buckets, then it's just, let's say that we have 1.5 items per bucket. Well, then the amount or the time to get an item out of a bucket is going to be, in the worst case, O of 1.5. So the load factor, however, the load factor is defined as, okay, so this is our load factor. The amount of time to get one item. The amount of items per bucket. If the load factor is small, it means that there are more buckets than items, right? So, okay, basically, if you have more items than you have buckets, you're going to have a lot, it's going to be a larger amount of time to find those items, right? However, if it's too large, there are too few buckets. No, a small one means that we're dividing by a large number of buckets. So we have a very small number of item and a very large number of buckets. Whereas if lambda is too large, it's the inverse, because we have a numerator that is greater typically than the denominator, right? And if you get over 1 at that point, then you have too few of buckets, because you have 2, 3 objects, 4 objects per bucket, so you're having multiple collisions greater than 1. Okay, got you. This makes a lot of sense. A lot more sense than the book here. Okay, so let's first define some collisions. A collision takes place when an element key value maps to a bucket maps to the same bucket of or index of a hash array. Right. That's basically what a collision is. Two different keys mapped to the same bucket. Two different keys. When two different keys map to the same bucket or index of a hash array. Separate chaining so then if a collision occurs, elements can be chained together. Colliding elements can be chained together. Colliding elements can be chained together to create a sub structure via an array or linked list, for example. So substructure within the bucket of the hash bucket via an array or linked list, for example. And then I'm going to, we'll come over here, and I want this example. So I'm going to Shift Command 4 on Mac to pull up the screenshot indicator. Shift Command 4, you can pull that up easily. And I'm just going to drag and click this guy here. I don't want that little whatever that thing is. So hold on. Shift Command 4 gives me my little thing. Oh, no, not that either. Delete. So I want to take this guy here. Like so. I'm going to copy this guy in to my notes. So I'll do here, example, just like that. You guys can get access to these notes in my Discord on my GitHub. You guys, it's completely for free, and all my notes are in there. Just my own thinking and breakdown of these examples and problems, really trying to break it into more of a beginner to intermediate kind of terminology. This is really dense and oftentimes pretty hard to understand at times. Let's get caught up on some chats here. I think once you get super proficient, you don't need that stuff anymore, though. You can just do the compute in your head. Yeah. Richard, welcome back in. Richard's hyped for some Leet code today. Bucket has an array of linked lists. So I think the group lookup for each bucket in the array is O of 1, and then traversing through the linked list, and the bucket is O of n. Yes, exactly. It's been ages since I did this. Yeah, sounds about right. There's a pretty good drawing tool called Epic Pen that lets you draw your screen, which I find is pretty handy for doodling this sort of stuff, by the way. Yeah, I have like this whiteboard that I pull up sometimes. You know, that I just do drawings on, but I'll have to look up that one as well. That sounds cool. Epic Pen. Me with good old pencil and paper. That also works. Would be good for the stream. Yeah. Yeah, Zanab, we hit 1.5K. Thank you guys so much for 1,500 subs. I really, really appreciate all your guys' support, really cheering me on. But, this is also about you guys as well. You guys are working with me along every day, studying alongside me, whether it be actually what we're doing and reading here or watching on the stream or just independently on your own, just hanging out with and working on whatever project you might be in the background. Thank you guys truly so much for, joining me. We're working on making ourselves better together and, through computer science itself. So thank you guys truly. Okay. So then we have such thing called a load factor. That's what she said. So the load factor is the ratio of data items elements per bucket. Elements n per bucket, big N, right? So it'd be this is our ratio. That. So then we're going to say lambda right? Lambda closer to 1, or hold on. Lambda less than 0, or let me start, less than 1, closer to 0, preferably below 1. Lambda less than 1 is preferred as because this indicates that there are on average more buckets per item, per element, thus allowing for quick access, quick lookup, access / lookup due to less collisions, right? And then we'll say lambda greater than 1 indicates that there are collisions as each bucket contains more than one element on average, reducing our access / lookup time to big O of lookup time, right? So we'll say if you eventually get deeper on these topics too, would be super keen to tune in. If you eventually get deeper on these topics too, would be definitely super keen to tune in for a stream. I study it on the side. What's a lambda? Because when I hear that, I immediately think of anomalous functions, but I'm guessing they mean it's a different context in the book here. It's just a Greek letter of the alphabet, typically used in like math functions, right? Like in chemistry, lambda is the wavelength indicator in chemistry and physics. So just different fields have assigned lambda to mean different things, and so in this context, I guess it's just saying that it's typically in this context it's a ratio of right. I think it's wavelength is lambda in is right, and velocity is the Greek letter v, and then length is just L. That gives you the wavelength. Or something like that, if I remember correctly. Okay, so let me go ahead and throw this. I want to do this. We'll say good hash functions the core operations will run in O of this on average. The ratio, it's called load factor. As long as lambda is O of 1, the core operations that have yeah. So as long as it is O of 1, meaning you don't go greater than 1, you will have an O of 1 expected runtime, meaning that you have more buckets on average or a bucket for every item. So you can access every item in constant time via the hash properties or dictionary properties that we have in Python, right? Just like we're doing for our small business manager, we converted our data structure into a hash, a table, basically not assigning hash values, but we are assigning hash values to be of the form of item numbers. So that is technically our hash function, is our item number generation. We're not compressing those values because we're kind of arbitrarily adding items to an array that will be continually dynamically resized by Python as items are loaded and removed or whatnot, or converted. So there is no end game to the size of the data side, but it has the kind of the same principles apply. There's no compression function because the end goal, the end set of small n is arbitrary. It's unknown. It's up to the user. This is Data Structures and Algorithms in Python. You can get this access to this book for free online, or just quickly you can get it in my Discord completely for free as well. You can join in my description below, where I provide all of my resources like a roadmap for my learning so far. And we've been reading this book live on stream. We're on page 440 out of 770. So we have 330 pages to go. We are making really good progress. We're over halfway done. So yeah, it's been quite the journey here. Can you think of it as some sort of variable? Yeah, I think so. On certain contexts. Eclipse says, I still don't know why I had to know that when I took calculus. For real, my math needs work. Exactly. Yeah, Jacob, me too. We're going to be getting into some math here on the channel after we finish the Harvard CS50X course. We're just about to finish week 8. We have the problem set to go. But once we finish that course, we're going to be jumping into some math, starting with some refresher on Calculus 1, and then diving in further to discrete mathematics, linear algebra, and obviously continue on with more calculus. Zanab, that's funny. Jacob says, do you think picking up math is a bit easier, though, later in life after you know programming pretty well, such to have worked as a software developer? Math is a tricky one just because everybody it's really kind of, I don't know. I feel like math can kind of translate a little bit into all these variables and functions and stuff like that. So it has similar properties and terminology, so it can help translate that way. But um, math is also kind of like a different language in itself with all the symbols and things like that. So I don't know. I think it depends on the person and what they're passionate about. People like to be software developers that just like art, right? They like to design websites and the artistic sides of those things. Um, you know, so um, arrays can't be resized without moving all the items inside, which can take forever. Yeah. Depends on how far deep you want to go into math. I'd say discrete mathematics from CS is like an intro into proofs course for math, like CS students also doing math as a second major. Yeah. Yeah, we started the MIT discrete mathematics course, this 6.042J course. We have one lecture watch along on the channel, and I haven't watched another lecture since because I was like, oh my God, I do not want to do this right now. We got really dense really fast. Hey Charlie, welcome in. How's it going? Appreciate you for joining me again. What's been going on with you? All right, let's go ahead and transition over here. This is a good stopping point. I'm going to go ahead and take this definition and throw it into the almighty orb to see if it likes what I had to say. Your notes are solid. Just a couple of tweaks for clarity. Collision definition. Instead of a, quote, a two different keys, it should be two different keys. Right, perfect. Separate chaining. The phrase colliding elements can be chained together to create a substructure within the bucket is great. Maybe explicitly mention linked lists as the most common implementation via a linked list. Most common or array. Load factor explanation. You could clarify that when lambda is less than 1, it suggests fewer elements per bucket on average. Indicates that there are fewer buckets per element on average. Where each bucket contains more than one element on average, reducing our access S lookup. Perfect, I like that. So let's go ahead and take that and see what it has to say about it. Looks even better. Instead of there are fewer buckets per element, obviously there are few buckets per element. There are. Just my English is a little off. You might want to clarify that this represents expected time complexity in separate chaining. But for separate chaining, where if lambda, oh no, not that, is close to 0, when lambda is low, less than 1, the operations stay close to big O of 1. Like that. Let's see. Do you like that? Nice refinements. A typo. And separate. Oh, I spelled separate wrong. Indicates that a fewer buckets per element. Okay, whatever. I like it. It's fine. All right, let's move on to a Leet code problem here. Oh boy, what am I getting myself into? You know, this is the struggle with you guys in the stream, is that you guys always want me to do Leet code problems, but my brain just does not want to do these problems. It hurts. Like, it physically hurts to do these problems. I don't know why. It's just, I don't know. It's so satisfying when you finally solve it, but getting stuck is it's literally a physical pain. All right, let's throw an E. Let's look through the easies here. Let's see some chats. Maths, yeah. Oh wait, Jay, don't you? I want to build a project soon that will be a DSA visualizer for stuff like this in Leet code. So you'll have like a code example and a debugger, and you have to step through it line by line. It builds out the data structure step by step, or does a traversal, etc. And a visualizer. Code Wars is like Leet code, but I think it's more approachable for beginners. We should take a stab at Code Wars. I've never heard of that before. I do have to do Leet code for my homework for my DSA class. Well, CS50P problem set 0 complete. On to the next. Yeah, you did some Hello World. That one's really easy. It's a good one to get started with. All right, which one should we do? Acceptance rate, highest acceptance rate to lowest. Should we do easy ones first? Or acceptance rate? Um, I don't know which one to do. Which one should we do? Which one do you guys think we should do? You guys know me. You guys know my abilities. Smallest even number. That one doesn't look too hard. This one doesn't look too hard. You guys gonna hate me if I cherry pick out the easiest one of the bunch? Given a positive integer n, return the smallest positive integer as a multiple of both 2 and n. All right, let's try this one. Yeah, I've done the neat code roadmap. I've started that one, but I I don't know. I'm getting stuck on some of them, honestly. So I'm not really sure if I'm really ready to move on. Let me sign in over here. I'm getting stuck on like some of the medium ones, and so I'm not really I don't know about the pathway here. Like I cannot do valid Sudoku right now. I haven't attempted this one yet. Um, I haven't tried those ones yet. Um, I've read these ones, but I haven't tried them. See, we're kind of done with some of these easy ones here, and we're kind of moving on to these medium ones. Search a 2D matrix might not be that bad. You're given a matrix n times m. Each row in the matrix is sorted in a non-decreasing order. The first integer of every row is greater than the last integer of the previous row. The first integer of every row is greater. Okay, yeah. Return true if the target exists, return with the matrix, or return false. Can you write a solution that runs on log m times n time? Okay. Log of m times n. Oh, so you have to divide it in half. You have to do a binary search on it somehow. So if your target is 10, you want to find 10. You start on the value. Well, you have 1, 2, 3, 4, 5, 6, 7, 8, 16. So you'd go here. Okay, no, divide by 2, slice from there forward. You basically just do binary search and find the 10. What'd you say, Eclipse? You said, I will never move up to mediums and never again after I did that problem. Okay, we'll try it out here. Why not? Whatever. Let's give it a go. Okay, so we're given some matrix, which is a list of lists, where these are the rows. So for row, we need a target for row. So obviously the brute force method would be of n squared, you could just say for row in matrix. Then you could say for val in row. If val is equal to target, return val. Return true, so it wants to return true. If the target is, else return false. So at the end of this, we return false here. So that would brute force it, I believe. Right? So you go and access every row in the matrix. You evaluate that row for the target. If it's not, you move on to the next one. If it's not, you move on to the next one. So this would find the 10 right there and return 10 there. So, right? Anything else I'm missing for the brute force method here? All right, the brute force method, that worked. I'll submit the brute force. All right, brute force method worked. That was a quick one. Now can we optimize this? Right? So this is the brute force method. Big O of n squared. So now we need to do it in log n times n. So we need, let's say you evaluate, we need to find the middle value. So we want to take the length of the matrix, which will determine how many rows. So the number of rows is equal to the length of matrix, right? So that gives us the number of rows, and we want to first start on the middle row. So middle row is equal to num rows divided by floored by 2. If middle row is middle row or modulo 2 is equal to 0. So if it's an even number of rows, then we need to access the row that is middle row minus equal 1, else middle row, else no continue. So we don't even need to do anything, no else statement, because we want to stay on the one that's greater. Is that the rule for binary search? Zanab, chill. We ain't cheating this one. Jacob, hyping me up. How are you learning Python? I learned through Harvard CS50P. It was my first introduction to programming ever last summer 2024. I completed it very part-time over the course of that summer, so those 3 months. I was on vacations and working, and I was just trying to get a dabble of, I was just trying to get a, Richard's pissed. Richard's pissed I got off easy on this one. Sorry, Richard. He's been struggling on his own through some of these hard ones. He's like, the one I picked, I brute force it in 2 minutes. Sorry, Richard. You're funny, man. I know, I hate that, Priyanka. That always trips me up, is why they always give you that non-decreasing instead of just increasing, or like inverted order or whatever. Like they give you those little trip ups to try to, mess you up, and it's really annoying. Yeah, I started with that, and then I solidified the knowledge and information with the Python Crash Course book. I highly, highly suggest you guys get a copy of this book. Pick up a PDF version in my Discord for free. Link down below. You can access that and all my notes that I took alongside there. I'm currently going back through and uploading the practice or the Try It Yourself solutions to my channel, as well as I've already completed all the Try It Yourself solutions. I have a GitHub repo linked in my Discord and in my GitHub for that as well. So you guys can access those. Really, really does a great job of solidifying and breaking down and filling in the gaps of all of the CS50 information, the CS50P course. So really, really highly suggest you take a stab at that. Carlos in the chat, he can attest that he's been reading that book, and he is Carlos Salcedo, and he'll tell you that it's been great for him. Okay, so, right, so that's basically, we're trying to just binary search this thing, right? But, well, let's say you access an index, and you can access the index of that index. So let's say you access the last list and the first list, the first row. Is your value like anywhere close to there? No. I don't know. If it's greater than, go to the next row. What if that's what we do? What if we start on the row heads, right? So let's say that the row, we have a head of 1, a head of 10, a head of 14. We evaluate at the head if our row, if our number is greater than that, we move to the next row. If it's less than that, we go back and start at that last index and go forward back from there. I think that that's a good way of thinking about it. That might be a good approach rather than finding the middle point and working back that way. Let's try it that way. So let's say, let's get the length. So this is the number of rows. Let's start at the head. So let's say, how do we want to say this? So we'll say we'll access the head of the matrix. So matrix index 1, index 0, sorry. Index 0 is going to be this 1 up here, right? We then evaluate. Now, what will be our our for condition? For I in the range. Okay, so we know length of row. We have the number of rows, and then we can get the length of each row itself. So the length of matrix index 0. So that's the length of each row. So our while loop, we'd say like what? While rows? We want to evaluate rows? No, we want to say, or we could say use a loop to get these index points, right? So for I in the range of the number of rows, right? Right, and then we need to go for j in range of the length of each row. Right, so we're going to evaluate if matrix index I, so the first row, first call. So if matrix index I, index j is less than, or is less than the target, what do we want to do? We need to evaluate so let's actually say, not a loop here. So if the matrix index ij is less than the current target that we're looking for, we want to move to the next row header. So what kind of loop can we do here? Yeah, Outlaw, that's exactly what we're doing here. No, I did not pay for NeetCode full access, no. Okay, so if matrix index I and j is less than the target, meaning that we're first going to be, so while, we would say while I is less than the number of rows, right? And J is less than the number or the length of rows, maybe. So if so we need to first set I is equal to 0, J is equal to 0. If matrix I index J is less than the target, we want to increase I. I plus equal 1, right? We want to move down to the next row, okay? If it's not, elif matrix index I index J is greater than the target, right? If it's greater, so let's say we're on 1, and we're on 10 now, and our target is 8. So it's greater than the target. We want to move I down and J, set J so J would actually start at, sorry, no, J has to start at 0. So if J starts at 0, that's how we actually did the first one. But what if I want to move J? So I want J to have to start at the back of every row, basically. No, because I don't want to evaluate that number. So let's not evaluate J here. Let's leave J at 0. Find the point at which our number exists, at which row our number exists, right? So if the matrix at 0, 0 for the second row, or in this case 1, 0, is greater than the target, then we want to move I back down and set J equal it's greater than the target. We want to move I back down. And do we want to leave J at 0 or run a loop? We want to move I minus equals 1 and then say for J. So actually, we won't set J here. We don't even need to set J. We can just say zero here, 0 here, and then say for J in range of the length of the row, if matrix index I index J equals to target, return true, else we'll say we want to increase J. J will go forward. So let's say you don't find one, we're going to return false here, and then here, else return true, like that. Yeah, I was thinking about that. If I do another loop, I ruin my time complexity, right? So I think this is one step above the previous one because we're not checking every value, but it's still not the best solution. I think this is a solution though. We're going to check the head of each row. If the value we're looking for is greater than or less than, we're going to move or increase the row, and then if it is, and then we'll do the search through that row basically. So we are doing, if our rows are m, no, n is our number of data per row. We're doing O of something, so the number of rows. So we're doing we're doing O of length matrix times n. So we're doing O of m times n, not O of log m times n. We're doing O of m times n. This is O of m times n, not O of log m times n. We're not doing any division by 2 here to create that log, or dividing our length by 2 basically, right? So this is O of m times n, time complexity, not O of log m times n. Now let's see if this even works. So let's see. So while I is less than the number of rows, we're going to iterate over all the rows. If matrix index I is 0, so the head is less than the target, we're going to increase I to the next row. If it's less than the target, we're going to decrease, and then we're going to iterate through the row and evaluate I plus j increasing. Return true, return false. I don't know. Maybe that wrong. Oh, yes. Okay, let's see if that'll submit. No. Oh, my heart. My heart. Oh, false. Okay, so if the while loop, we need to return false here as well. No. No. Shoot. So where do we have a problem? They tell me the thingamajigs? Doesn't tell me the wrong answers that I got. Oh, shoot. Yeah, the edge case has got me here. Hey Santiago, are you following a guide for the order of the topics you study? I'd love to know. No, this has all been my own research and understanding of what I think I should start with and whatnot. I have asked for a lot of suggestions. Um, I have asked for a lot of suggestions on what to learn from you guys, but actually I haven't. This has all been like kind of my own, like just throwing darts at a board here, I guess. um. So what if the edge case, if it's not found? So why didn't this work? Right. So I got target is 3. I should have, so in a single row. Okay. So while I, so we have to say if if length of if the number of rows is 0, or it's 1, I mean. So in this case, what happens? Our target is 3. So we're first going I equals 0 is less than number of rows. Okay. Number of rows. Oh, so we need less than or equal to the number of rows. So now that should hit. So these are our, let me copy this. Go to my test cases, add a case. Matrix of that, target equals 3. Oop. No. 22. 22. So I is 0, 0. Why does this give me index 0 out of range? Matrix index I, so it would be the first index 0, the first here, and then go into the first value, 0. If it's less than the value. Oh, it's trying to increase I right here. And then doing the loop again. Okay, that's what's happening. So it's increasing I, doing the loop again, and then it can't do it. So we basically have to say, okay, so I'll scrap this one. Nice idea, though. Fun idea. Oh, my fault. Sorry. Right. Okay, so that one didn't work. So let's go ahead. Can I shift these over? Okay, so let's go ahead and then let's look back here. So if we want to do binary search here, how would we do binary search on a matrix? So if I get my number of rows equals to the length of matrix, and we have the number of rows length equals to the length of matrix index 0. If matrix Okay, so if we have values in the matrix, we'll go ahead and take a length of that value, right? So if we have matrix, we need to do the same thing, I guess. We'll say if not matrix, return false, do this, and then we can just go like here, delete this, move this down, like that. Okay, so that'll take care of that. So if not matrix, return false, number of rows, length matrix, row length is length of matrix index is 0. So how can we perform a binary search across a matrix? So we need to find the middle row, basically, right? Like we were trying to do before. Yeah, right? Kind of started on the right path. So if we say middle row is equal to the number of rows floored by 2. If middle row modulo 2, so if the middle row is equal to an even number of rows, so in this case it'd be so we have middle row would be, in this case, middle row would be index 1. No, so we need to say if num rows modulo 2 if the number of rows divided by 2 is equal to 0, meaning we have an even number of rows, so like a 4 by 4 matrix, then we will say that the middle row is equal to the index 1, which will be the even, which would be floored. So 4 divided by 2 is 2, so we want to leave that as it is. So if rows modulo 2 does not equal to 0, the middle I forgot this part. Div mod x and y will return a tuple that will be the quotient and remainder. Oh. Quotient and remainder. What do I want to do with the quotient? So if the number of rows, if we have an even number of rows, what do we want to do? Well, in order to perform, let me open up my DSA in Python, chapter 7, linked list 8. Search and short. No. Where's my binary search notes? Recursion. Big theta. It's got to be back in trees, I guess. Binary trees. Traversal algorithm. I thought I had notes on binary search. I know I do here. Let me go up to my algorithms from week 3. Sort, recursion, bundle sort. Binary search here. Middle. That doesn't really help me either. Hey Brian, how's it going? Welcome back. Okay, so if we have an even number of rows, what do we want to do? So in this case, we have an odd number of rows, so we set the middle row to this guy. And then we find the middle value of this middle row. So if the number of rows modulo 2 does not equal 0, meaning that you have an odd number of rows, middle, so 3 divided by 2 is 1.5, floored down is 1. So middle is equal to middle row is equal to the number of rows modulo floored by 2, right? Else, right, middle row is equal to the number of rows modulo 2 plus 1. So if we have 4 rows, our middle row would be index 2, which would be the third row. So we don't want to do that. We want to make it 1 back to the index of 1 so we can get the second row. Perfect. So now that'll set up nicely for getting the middle row. Now we need to determine the binary search of the length of the row, right? If length, so we can do that evaluation. So we'll say here, if the length of the row, if the row length is modulo 2 does not equal to 0, we want to set the middle value equal to row length floored by 2. Else, middle index, middle value index is equal to the row length floored by 2 plus 1, or minus 1, sorry. Right? Convert that into the middle index. So div mod takes the yeah, I need to learn more about that div mod, I guess. So this gives us the middle value index of the row, and this gives us the number of rows. So we say if so we're going to say while what? While matrix index need to do 2 pointers for the row. Okay, no worries, Jacob. So while matrix index what? Middle row, middle value index? While matrix middle row middle value index, right, does not equal to target, we're going to, what do we want to do inside the loop over and over again? We want to no, so I don't want to. So let's look up, can you give me a simple binary search example in Python on a basic array? Let's just get an example, right? So you have an array given and a target, left and right, 0, length of 1. While left is while left. While left is less than or equal to right, we'll continue increasing the left. If array at mid point is equal to target, return mid. Elif is less than, increase, left is equal to mid plus 1. Else, set the right to the left half. Return not found. Okay, so while left is less than or equal to right for the two-pointer approach. But we need to first figure out, pretty much we need to do what? 2 binary searches, one across the heads and then one across the row. Right? If we do a binary search vertically across 1, 10, and 14 and determine which row the value would correspond in, and then do a binary search on that row as well, because we're doing log times times, right, which would be log n times log m. So that's exactly what we need to do, is do a binary search across the 1, the 10, and the 14, figure out which row the value would be in, and then do a binary search across the row. So while so we need to write 2 binary searches then. So we say left is equal to 0, right is equal to the number of rows minus 1, right? We then say while left is less than or equal to right if matrix index left zero if matrix index left 0 is less than target, we want to search the left half. No, the right half. If it's less than the target, we need to set left equals to no, but we need to do the midpoint though. So mid is equal to left plus right floored down by 2. If matrix index 0 left and 0, so this guy is less than the target, which it is, we want to move our left pointer up by so let's do first equal. If it's equal to target, we want to return true here, right? And then elif matrix index left 0 is less than the target, right? We want to search the right half. So we want to search this row here. So we want to increase left is set to mid by 1, increase by 1. So mid, no, on the left, mid index 0. Mid, matrix at mid index 0 is less than the target. So in this first pass, it's going to be at 10. It's going to return the target, okay? Right, in that case. Perfect. Let's say that our target is 30. So in this case, it's going to evaluate this 10. Okay, it's less than the target. So we're going to set our left pointer equal to mid plus 1. We want to increase down to this one, right? Else, right equals the midpoint minus 1. Okay, so that will do the binary search across still working on it. You're a baller for going off for the optimized route. Thanks so much. I appreciate you. Richard, you're awesome. Hey, Edwards, how's it going? Welcome back. Okay, so then we set the right, perfect, okay? So we're searching for, if it's less than the target, we increase mid left, and then we need to do a binary search across this for the row length, basically. So then my thing is do I want to nest another one? No, I want to basically pass in call bind search on the if it's greater I want to call basically another function to do search on that row. So if it equals return true, if matrix mid 0, so they're here, is less than the target, we want to go to the next value. If it's less than the target and okay, so we need to determine if it's in this row though. So if it's equal to the target, we'll return true. If it's less than the target, we need to search the right half, right, by making left pointer equal to the mid. We want to then also evaluate though if it's in this case less than that guy. So and matrix index mid plus 1 index 0 greater than target if it's greater than the target, that means we're in this row. So we're going to perform a binary search across this row. So binary search given the matrix index mid if it's and target is less than we'll make it easier to read. Right, matrix binary search mid, right? So we'll just do a binary search across that row. So then we'll say the opposite, elif matrix index mid index 0 is greater than target, right? Right. And target is greater than matrix mid minus 1 index 0. We're going to call binary search on matrix mid here as well. If the target on if it's greater than, we want to call it on mid plus 1 here, and then on mid minus 1. So then what we can do is probably set this up recursively. But I don't really want to do that, so we'll say def binary search, which takes in a array. We're going to basically say that we're going to say left is equal to 0, just like in before here. Right is equal to the length of the array minus 1, while left is less than or equal to right, we are going to say if array index, we need to find a mid is equal to left plus right divided by 2. You guys are funny. Yeah, am I on the right? Because I have to just do a binary search across the heads and then do a binary search across the row, thus giving me log m times log n, right? So that's all I need is just two, basically not nested in this case, because they're not nested. They are nested, but they're binary search. They're not iterating over n and n. So left mid plus right. Then we say if array mid is equal to target, return true. If array mid is less than the target, right, guys? Right, we want to return, no, we want to say left equals to mid plus 1, else elif, right, else right equals mid minus 1, and then if we don't get it, we're going to return false here, like so. Same if we don't get it here. So what happens now? I'm running a binary search across these head values. So if the current value I'm on, the mid head value, is equal to the target, then I return true. So right in this case, I would return true. But let's say my target is 30. So in the case my target is 30, so if the matrix mid 0 is less than the target, which it is, and the target is less than no, we want to do it on that value. We want to do it on the mid. If it's greater than that one, but less than that one, we want to do it on that value. Elif if it's same in that condition. Else, if it's greater than both, oh shoot. What if you treat each row as an independent array, therefore you only need to apply binary search one time? Okay. So, yeah, each row is their own array, right? I just need to find the applicable value, the head point, basically. If row, so do you want me to evaluate a condition and say, a pointer basically for the end of the head of every row and the end of every row, and evaluate if the value is in between those, and if so, perform a binary search or go to the next row. But it wants log of m times n. So log is being applied to both m and n. So I'm doing two logarithmic functions in parallel, not nested, but right? So if we have our binary search here, to do the binary search across the array provided, how can we determine which row the value is in? Well, I'd have to just evaluate if the number is within the head and the tail of each row. But that would have to have me evaluate O of m rows, right? Not a log O of m rows. Right? So I'm a little bit tripped up on the time complexity part here, right? Because the logarithm is being applied to both the m and the n, which is the matrix number of rows itself and the amount of data in every row of the matrix. So it wants me to run a logarithmic function across both the number of rows and the data inside every rows, thus having, two binary searches happening in parallel. I don't know. I'm trying to talk my way through this, but but what you guys are trying to suggest, right, are saying that by having one binary search, I have to that then. So what I'd have to do a linear search across the headers of every row, right? Because that's what my next thing I'm getting into is the log is being applied to both variables. So if I just do a simple linear for loop across the headers of every row and evaluate if it's greater than the target, if it's greater than this value, then move on to the next one. If it's less, then just go with the value you're currently on, right? The one that it's saying here, O of m times n, where the O of log m times n, where the log is being applied to both the m and the n. So a logarithmic function is being applied to both the number of rows and the number of data in each row. So my initial thought was to do a binary, so treat like this column here as an individual array itself, and to find basically do a binary search across this array of a column to identify which row the number is then in. The single for loop single function is said to give the time comp you want. Okay, so then if I have a binary search function written, I say for row in matrix if row index 0, if row index 0 index, no, if row index 0, so the first value in the row, is less than the target, and less than row index so if the target is less than the row of the next row, right? But I have to have that check that edge case, right? So if row length greater than 1, do this check, else the row length is greater than 1. There's only one value in the row. If row index 0 does not equal to target, return false here, right? That'll handle for the edge case of a single column data point in a row. Okay. Well, they're going to say hey Rajiv, how's it going? So far the easier codes are very close. Use for Jacob says he's close. Yeah, we're just learning for fun. For those that are new here, my name is Michael. Thanks so much for joining me. I'm 26 years old. I've been teaching myself how to program for a little over 6 months now. I started from literally no experience ever. We've written a couple of projects in Python so far and have completed a couple of courses and read a couple of books. We've been going through some Leet code and doing some DSA in Python. At the beginning of our stream, we do reading in DSA in Python. I graduated from college back in 2021 with a degree in human biology and a minor in chemistry. I work as a formulation chemist for a biotech company. I've been learning this just for fun, basically, to improve my skills, and I just find computer science to be fascinating, and I want to learn more. I am a learner at heart. I'm fascinated by a lot of things in the world, and I think that computers are one of the most interesting things that humans have ever created, besides, maybe landing on the moon, which was done by computers. So it's really crazy that what we've been able to accomplish because of computers, and so I want to know more about it and know like how to be able to do stuff with it myself, and that's really what sparked all this. And if we can translate that into some biology and chemistry work later on, then that'd be great too. But okay, so we're accessing every row in the matrix. We're catching the edge case if the row length is less than is right is greater than 1. We'll go ahead and determine this value else. So if the target is in here, right? So if the target is within these bounds, we're going to call a binary search function that we wrote on the row that we're currently on, right? Elif row index 0 elif row index 0 no, so this, sorry, this shouldn't be row length. Yeah, wait. Yeah. Okay, so elif row index 0 is greater than the target, right? And target is greater than row. So the target is less than the row. Okay, actually we don't need to do this condition basically because we're going to move on automatically to the next row. So if it's within this bound, we're going to do the binary search or we're going to move on to the next row. Okay. Yeah, so if you guys want access to all my notes and resources, I have a Discord server linked down below. I've got over 450 people, 450 of you loyal subscribers and followers and learners along with me in there, where we share a bunch of online community resources as well as my own resources and all my notes that I've taken live for our notes that we do live in the like DSA and Python, right? All of our notes that we take here. And then I have all of my practice problems and my courses and course information in there and books as well, PDF copies of the books, right? So if you don't get it, I'm going to return false here. If it's equal to 1, then let's go ahead and do this. Right. If the row length is equal to 1, we'll do this. We'll check if it's equal to target and return true. Oh, true. Else return false. No, we don't want to return false. We want to basically continue. We'll say here elif row else, not that. We don't want to return false here because we want to continue the loop. So we'll exit out there and the catch will be caught there. So how does that look? So what we're doing is I'm looping over the rows in the matrix. So every row, right, through this, let's look at this visual example here. Every row I'm looping through. Or I'm just looping through to get access to each array. So every row, basically. I say, okay, if the row length is 1, access the first value. If that is equal to target, return true. If it's not, move on to the next one, okay? Okay, if it's not, you're going to evaluate this condition is if the target is less than or greater than this value and less than this value, you're going to call a binary search on that row. The only thing we might get an index error though for this call here. Well, no, because we're calling row length greater than 1. So we at least have one more value. No, but this is number of rows. Can we assume that we are always given something? Each row, we're never given an empty one, an empty matrix. So we can assume that we always have values in a matrix. So I don't know. Let's see. All right, let's try to run it and see what happens. Okay, line 21, we got some syntax error. Syntax error. If row, equals to 1. Okay, we passed test case 2, failed test case 1. So this returns false. So we're returning false no matter what here. I've already solved the problem in brute force, my friend. If that's what you're trying to allude to. We're trying to optimize it here into the appropriate time complexity of log m times n using binary search. So we are looping through the matrix. We're trying to catch these edge cases. We're accessing every row, and we're trying to evaluate if the target is within that row. If the row index 0 head is less than the target, we need to evaluate if we need to figure out which row to call the binary search on. So that's what yeah, we solved it in brute force in literally like 30 seconds. You can go back in the stream and look for 45 minutes ago. But now we're trying to figure out this binary search problem. I don't have a lot of practice with binary search, so okay, so why are we returning false at every point? Can I run my debugger? Let's see here. Report bug, no. There's no debugger in this? No? Jacob, I think I got it. ... never mind. Okay, so why am I, what am I returning here? If not matrix, return false. We get this value. For row in matrix, if row length, so the row length in none of these cases, this row length is 1. No, this is, oh, so let's say if num rows equals to 1, call binary search on matrix index 0. Okay? So if the number of rows is equal to 1, we're going to call binary search just on that row right away, no matter what. Do I want to call binary search across every row in the matrix, or do I want to do an evaluation I'm not updating mid correctly? Oh, whoops, you're right. I thought I put that in. Did I delete it on accident? Okay, so what happens when I run that? So get those, I think. Cannot access local variable. Oh. But false. That should be binary search. Oh, search matrix. So let's back that up there for the class. Takes himself. Second here. Okay, I need to pass in a target. Right. Okay, so now I at least run, but I'm still outputting false across the board no matter what. So let me just, what happens if I just run a binary search across? We'll say if binary search on row turn true. So that'll return a value. The is condition will evaluate it and will return true. If you get this value, else will return false. If self.binary search. Because now we're just running we're running the search across every row in the matrix, right? And returning true if we get that. Else we're going to the next row, basically. Okay, so what happens if I run that? If row length equals 1. Let's just keep it simple and try that. So if rows. So I don't even think we need this then either, because it'll automatically access the row in the matrix. If self.binary return false, let's return true. Okay, so now if I run that target, shoot. Self-dot binary change. Boom. Okay, we passed there. But we're running a binary search across every single row, which I don't think is also wanted. Right. So, because we're running the binary search across every single row, like, so I guess that meets the time complexity then. But we're not running the logarithm on the row. What do you guys think? Is that the answer? Or is there still a better way to do it? This is what I was able to get here. This is my brute force, and this is my optimized with binary search. I'm specifically, I'm doing the binary search across every row though, deliberately. So I don't know, I could do a conditional to check the values. Yeah, this would be m log n, right? Because I'm doing a linear search across every row. So I need to do a binary search basically across the row heads like I was doing. M log n. Dang it. So for row in matrix, if row index 0 is less than target, pass. So we only want to do it on rows where the first value is greater than the target, because then we'll specifically cherry pick values of our small n that are greater than the target. So this is a little bit better of approach, right? Oh shoot. If row index 0, the first value in the row is greater than the target, no, less than the target. Okay. So that will cherry pick out rows where the target is initially less, so it won't do, so that's a little bit better. Yeah, that's what I was doing before, an inner and an outer binary search. So let's say call a binary search across I need to get so I don't want to do for row in matrix. I want to say binary search on self-dot binary search target. For the array, we're going to input so we'll say for I in the range of so we have to do a binary search across the leading values of each row. So for I in the range of the number of rows, right? For I in the range of the number of rows, 0, 1, and 2, no, because we'll need to do the left pointer, right pointer. So left equals 0, right equals to the length, the right equals to the number of rows, right? And then we say while, so we're pretty much going to do this. While left is less than or equal to right, we are going to say yeah, that's what we're doing here. We have a helper function binary search here. So while left is less than or equal to right, we are going to call if matrix index 0, no, index left 0, like that, equal to target, return true. Elif matrix index left index 0 is less than the target, we're going to do a binary search here and set the, not binary, so we're going to set the left equal to mid plus 1. We need to set the mid equal to left plus right floored by 2, right? And then we'll say else else we'll go right equals to mid minus 1. So we'll set that. Then after the loop, what are we given with? After the loop ends, we are left with a matrix at point so what are we left with? Where should we call now the binary search? When the while loop ends, the binary search is over, and we return back for accessing the first one. We're saying, is this equal to target? No. Okay. So we're elif, it's less than the target, yep. So we're going to set the mid, which is 10, left equal to mid plus 1. Is equal to mid. Oh shoot, okay, what's going on here? Hey Dylan CDN, how's it going? Thanks so much for coming in and chatting with me on Twitch. You're awesome. We got a viewer on Twitch over here. Hey dude, welcome. Call binary search on the first element for each row, then run in on row and find column. Yeah, that's what I'm trying to do here. I'm calling the binary search on first element in each row, then run it on the row when they find the column. Yeah, exactly. So I'm just trying to figure out now where do I insert here the binary search call for that row. So at the end of this iteration, so it's going to say, okay, here in the first pass, target mid is going to be equal to here, this index. Oh, so this is matrix mid, sorry, that's why I'm confused. Mid. If matrix mid 0 is equal to target, return true. If the mid value is less than the target, or greater than the target, then we're going to set the left value to mid plus 1 and search the greater than. Else, we're going to set the right. So yeah, at the end of this loop, we're left with a row that we call binary search on. Matrix mid. No. Oh, whoops. Not defined. Oh, self dot. Target, shoot. Up it's none. Oh, so I say this returns true, this returns false. We'll return that call. There we go. Oh, okay. So now we need to have this edge case checked. So if matrix mid index 0 is equal to target, list index out of range. So what is my, so in the case where there's a single row, I can't access this. So if number rows is equal to 1, we're going to break. No, we're going to return self.binary search on matrix index 0 given target. Oh, no. Target is 15. This index out of range. So this is my matrix. Copy this over to my test case. And then put my output 15 target. So I'll fail test case 3 here. So I say, well, blank output. Solutions. If matrix mid index error out of range. Here. Um. What happens if your 2 pointers and the helper converge and pass each other? At target still. Well, it's while it's less than or equal to, so they won't pass over each other. Less than or equal to. List index out of range. So I'm getting this list index out of range now. I'm not getting any output. I'm failing on here. So it's going, it's doing it, returning true. Mid. Oh. No, that does mid. So in this first case, left is 0. Let me left. We don't want the right. Be less than? It passes that one now, but fails this one. So then I don't need to edit that in my binary search as less than? No. Ah, shoot. We're really close, but no cigar here. Hold on, let me check my cell phone. I have not got any messages here from my girlfriend. 1 second, guys. Okay, we got some time here. There's 2 steps we need to nail down. First, we're doing the outer function to do the outer measure. Then once that's complete, probably add in the inner search and the helper. So we're doing a binary search across our heads of our rows. So if the number of rows is equal to 1, we're just going to run a binary search across that row. If it's greater than 1, we're going to get a midpoint. So let's say if it's 2. Oh, so we need to evaluate what about the condition where the number of rows or the number of columns is even or odd? Right? Do we need to determine the midpoint is even or odd given the Hmm. So left equals 0, right is... I say my right is my number of rows. There we go. Oh. What did I fail there? 11 should give me true. Why? What edge case is that? Hmm. Um. Initialize the left pointer on line 28, correct. I need to do -1 on right. We had to do -1 because we want the right to be the last index, not the out of bounds index. So why is this giving me false now though? For a target of 11, given that these arrays are even or odd. So odd lengths, whole number, rounds down, cases. So your last two conditions in the first loop on line 35. I don't have time to take a break. I only got about 30 more minutes where I can stream, and I want to solve this problem. um, so my test case is passed here, which is so frustrating. Why doesn't that it's so annoying. They give you 3 test cases, but only. This is what I have so far. This is my entire solution here. So if you don't have anything in the matrix, you return false. We get the length of the rows, and we get the number of rows, and we get the length of each row, right? We then set our left and right pointers, the number of rows, right? We do a binary search across the heads. I'm able to pass all 3 test conditions, but I fail one of the edge cases. 33 to 34. So if the mid is equal to the target, if the array mid is equal. What do you mean It's my line 33 to 34 is my first problem. If A index mid is equal to target, return true. Hey, Not Neil, how's it going? Welcome back. Thanks so much for joining me. If you guys are enjoying the struggle here, consider leaving a thumbs up for my struggle. I really appreciate you guys. I'm trying to convey a real authentic beginner perspective and trying to learn this and teach myself these topics. So I really appreciate you guys joining me here and helping me along. We've been working on this problem for 2 hours now. Holy crap, time is flying. Oh geez, I wanted to work on the small business manager. But this is why Leet code is kind of annoying in my opinion, because I get sucked into these rabbit holes where I'll work for 2 or 3 hours on some problems and then I miss out on being able to work on all the other stuff I want to do. I don't like looking up the solutions and videos. I like pushing myself to try to think beyond my grasp and look at new angles. And so if the array at index mid is equal to the target, we return true. What? I don't get how these lines are incorrect. Hmm. Hmm. If A index mid is equal to the target, we're returning true. So you are moving the pointers. You said lines 33 and 34 were what I have wrong. Are you suggesting that it's 35 and 36 you mean? Target less than a mid left. If the target is less than no, SA mid is less than the target, meaning that the target is higher when I set the left equal to the midpoint. If we set the left equal to the midpoint, we want to move the left to the midpoint. But we don't want to evaluate the midpoint. But line 33, you want to be checking if the target is greater than the first value in the current row. you want to be checking if the target is greater than the first value in the current. Makes sense. And your helper function should have logic to separate binary search. Separate binary search on the inner list / array. What's your confidence feeling? And plus one. All right. Yeah. So if so, but for line 33, you want to be checking if the target is greater than the first value in the current mid. Yeah. So I'm doing that right here. But I have this check to basically, you don't even need to do this elif check if you pass this check right off the jump. In this first example, you would pass that check. So if it's equal to the target, you return true. Elif, that value at that array, is less than the target. We're setting the left pointer equal to the mid value plus 1. So we have this whole array. Find the midpoint. Is that equal to target? No. So it's greater than the target. So we set the right pointer equal to mid minus 1. Can I see the examples? Yeah, here. That I passed? Oh, yeah. These are the examples I passed. A is just an array. Looks like you're just checking the first value in the outer array and not probably checking if the value exists, falls within the mix, and min value of that inner array. Okay, so you want me to check the two-pointer approach for min and max then. So we'll say if matrix return true, elif matrix index mid 0 is less than target. Do I say and target is less than matrix mid index right? length of row length. Should be the right pointer. So does this have to say and matrix mid right and target is less than this? If target is greater than the first value in the subarray and less than the last value in the subarray, So if it's less than the matrix mid right, we're gonna set left equal mid plus 1. No, we don't need to even do that really. We just need to call binary search on that row. So left, if it's within these bounds. So in our first case, we're going to have 0 for our left, and our right is going to be 4, or it's going to be 3. Sorry, 2. So 0, 1, and 2 for these indexes. It's for the 1, 10, and 14. We get a midpoint by saying 0 plus 2 divided by 2 is equal to 1. So that's the midpoint right there. If that is equal to the value, return true. So, okay. But if this value is less than the target, and the target at the right is inside of it, we're going to run a binary search on this row. We'll break. We'll break and do the binary search on matrix mid with target. Else, what do we want to do? If it's not within the bounds of this current so it's the matrix. Less than target. And the target is less than. We have to include an equal sign here because we want to do it if it is equal to this one. So we don't even need this guy here because we're doing the binary search Well, we'll keep that just in case, just for a quick checker to pull us out. But then we can leave this here as that, and that we want to break and run binary search on this current value of mid. But how do I increase my left pointer? So if, oh shoot. So right is a number of rows minus 1, so that's right. That's perfect. Right. So then what do I do with my left pointer? I don't need to do anything with my left pointer because technically I'm already at that point in time. You need to check the target against the first value of the inner list and the last value of the inner list. Yeah, that's what we're doing right here. If the target is greater than the matrix first value of that row, or it's less than or equal to the last value, we're going to break and run a binary search on that and return the target if found. But then how can I get my left pointer to increase? Just like here. So elif target, increase left, and then increase mid. I'm not having that much fun, Richard. The problem is the original binary search won't work since you won't have the exact value, or better to say, you don't know if the target is on 0. So you need to be checking for the ranges. Yeah. So then what do I do with my left pointer though? That's what I'm trying to figure out. Is if my left pointer, where do I increase my left pointer now that I am no longer, which is this, right? This is what I got so far here. Columns. Hey Yams, how's it going? Thanks so much for coming in on the Twitch chat. Appreciate you for jumping in and saying hello. What's going on with you? Thanks for popping in here. Let me see where my girlfriend's at. Make sure she's okay. 20 minutes. I got 20 minutes here, guys. Let's stop function now. Now to fix, if you know is higher than the target, you use the left half. Now to fix, if you know the index 0 is higher than the target, you use the left half. But if you want to use the right one, you need to make sure that the right of that interval is lower than line 28 through 40. This is just my binary search function. Mid. True, false. What is it not like about this? If I can provide a video, if not, a return false. Chill, Mahan. It's all right, bro. Let's fix the outer search first. We need to fix 90%. I don't think about the inner search yet. 34, 35. Why are you so caught up with this here? This is not going to return true if this is not true. It's going to move on to my next statement. Like, I'm returning true because I don't need to do these other checks if I have that value. Yeah, so like how is your function above being called to do the inner search? The function above isn't being called anywhere. This is the function that's being called. This is my helper function. Okay, let's see where we're wrong. It's about that time. Sorted. Okay, so link matrix 0. No, wait, plus 0 matrix mid. Left equals 0, right equals nose minus 1, while left is less than or equal to right. If matrix mid 0 is equal to target, return true. Right. L if matrix mid 0 is less than the target, and the target is less than matrix mid row length. Row length times 1. So this should be. This needs to stay row minus 1. There. We call binary search. We return the value here that we take. There. And then we do the elif condition, basically. Again, matrix mid is less than index 0. Right, is less than the target. That's when we'll do the increase. So that's what I was missing there. Else you do the right and you return false. There is no loop found in all of this, right? So our binary search, left, right, say minus 1, while left and right, return true, maybe plus 1, return false. I think that's it. Shit. If not matrix, return false. So let me actually get rid of this. Run that. Row length minus 1. Oh, row 1. Okay. So I had like a modge podge of ideas together. So I search if it's inside. If it is, I run the search. But I need to evaluate also to move my left pointer forward and my right pointer forward. So I still have to keep this elif if this one isn't satisfied. Okay. I did this in one of our past iterations of an attempt. So I just needed to combine my ideas together then. There it is. Right. So then the left binary search. I just needed to look up this one part here. I didn't know. I wasn't sure of how to get the left to continue moving, and so if this isn't true, then you still can evaluate that first condition, right? Right, without this one to move that left pointer, right? So that's what I was confused on, is I still could evaluate that condition despite this one failing, because I just needed to specify with it in this array. Because before my n log m attempt, this one here, this one does a similar purpose, but it just loops over every row, right? Rather than doing, and then does a binary search across every row. Now this one specifies the individual row head against the row tail first, and then does a condition on the row heads only. Ah, here we go. There we go. You've been close as like 95% of your first 5 minutes. Yeah, I know. I've literally I've had like a somewhat close. What's really frustrating, you guys, is I've had a really close attempt almost every single time. Like I was able to like get like 90 or 80 to 90% of the answer within the first 30 minutes or so, but then the next hour and a half I just go through these edge cases and these conditions. It happens every single time. Literally every single time I get very close within the first 30 minutes of my work, and then it takes me about another hour and a half to get the last 10%. I don't know why it always is that. It always is like that. No problem, Mahan. It's okay. I just appreciate you being here and just hanging out in the chat. It's fun. We're just learning. It's okay. I really don't care how long it takes at the end of the day. I know I can act frustrated and all that jazz, but I I really don't care how long it takes, because I'm having fun doing this, and at the end of the day, and solving problems and learning. The whole point is I spent a good 2 hours practicing binary search here. So I got 2 hours of trial and error, trial and error, trial and error. So now binary search is that much easier for the next time we try it. Yeah, I think it's just honestly a little bit of Python JavaScript discrepancy here. Is why you might be confused. I'm calling my inner function right here. So this is an object-oriented approach, right? I'm not sure if they have that in Java. They probably do in JavaScript. I'm not sure, but I'm calling an instance self from this search matrix function, so I could call the helper function of binary search. So that's what's happening right here. So then my next question is what if I kept that and then just remove that? That still works. And that still works. Okay, so this one's a little bit better because you just do a little bit of a catch right off the jump. Um, right? You just do a catch right off the jump. If the number of rows is equal to 1, well, I don't even need to do a binary search, evaluation across this. I can just return right away a search across that one row, right? So this one's a little bit better. And I say that and I got an error here, runtime error, invalid syntax, elif. Oh, because I had that mid there. If, has to be if. Oh, enhancement. Cool. Um, I just called search matrix at the bottom of my file. Oh, okay. Yeah, so the class kind of already does it automatically here for the, I guess. Thank you so much for your help, Jacob Allen. Yeah, we'll have to set up, um, some Discord calls for like that peer coding that we talked about late yesterday. So shoot me some times that you're free, and then we can maybe do that. I know that my schedule is a little bit. It probably will have to be honestly like weekends work best for me. In terms of because I come home right from work, I get a little snack and I jump right on my computer and stream, and then I get off. I will either edit or I'm just kind of at that point I've already been working, I guess, in my brain for 15 hours. So I'm kind of just like done like at that point after the stream. So I don't have a ton of motivation after to continue on with like a call and whatnot. Kind of like Mahan was saying, I've been kind of ghosting him on the calls lately for one-on-one practice. So I've been just beat after my streams and anywho. Let me see here. Where's my almost here. All right. Jesus says, I'm just finishing a DSA course in C/C++, so I'm going to move into Leet code and these kinds of problems soon. I know I'm going to be frustrated. Yeah, you're right there with me, Jesus. I appreciate you. Is it Jesus or Jesus? Let me know. Richard says, I've been there. I'm sure we all have. LeetCode just does this to people. They say this is super good for us in the long run. You probably have some of this imprinted in your mind. Yeah, exactly. The struggle, there wasn't ever success without struggle, guys. Like the cringe cliche, what doesn't kill you makes you stronger. All of this, pain and anguish that we're going through is just learning lessons for our next time around. Really think of it as an investment into the next go around, the next go around, the next go around, little by little, reinvesting those dividends. You'll soon to be able to have a reward at the end of a long journey, right? Little by little. No, Jacob, you're hyping me too much. I'm sure you did great. You're awesome. Thanks for your help. Yeah, I don't know what it is. I have like a personal thing where like I really don't want to watch the videos. I don't know why. I feel like I lost. Like I think it's a competitive thing, honestly. You guys get that? Um, Same though, yeah. No, it's okay. I totally understand. It's hard to translate, especially if I was trying to translate into like C right now from Python. Like I know a little bit of C, kind of probably how you know a little bit of Python. So it would I'd be in the same boat. Your edge case is not needed. Even if you run binary search on length 1, it'll still be O of 1 anyways. That is true as well. Okay. That's a good point as well. Yeah, right. It's those 15-hour days, right? 8-hour workday and then a, you know, commute and then a stream on top of it. 12 to 15-hour days. Those will burn you doing these leak codes after a 9 to 5, especially if you're programming 9 to 5, where you're the last thing you want to do after your 9 to 5 is program some more, right? All right, thanks so much for coming in, Jesus. I appreciate you. You're awesome. Let me go ahead and just double check here. I know I've been checking my phone, but I have to open the gate sometimes to um, let my GF in. All right. Cool. If you guys enjoyed hanging out with me tonight, please leave a thumbs up. We completed this binary search problem on LeetCode, as well as completing some of the reading in data structures and algorithms in Python. You can find this reading and this book copy in my Discord link down below, as well as my personal notes on this whole entire book, chapter by chapter, example by example, problem by problem. We've been doing this, really trying to create a detailed breakdown for beginners on these more complex data structure problems and topics. So these notes are really useful. You can access them in my Discord and on my GitHub. So feel free to join that. I really wanted to work on the small business manager today. I just don't have enough time. My girlfriend's coming home tonight after being away for a while, so I'm gonna spend some time with her. But and she's bringing my dog back tonight, so I'm super excited to get my pup back. But I wanted to work on the small business manager tonight, but just didn't have enough time. I did write a little bit on my lunch break today of, I started to actually refactor this code into, so now I have an inventory.py um, file that houses all the inventory functions. And so I'm starting to break this down and to organize it a little bit better so it's just more manageable. Already I found that it's a little bit easier to read now that I've kind of reallocated the inventory. I'll do the same for expenses, and then I'll do the same for maybe like operational or miscellaneous functions, and then I'll keep my main like menus within the actual main program here. So it is pretty cool. I did do a little bit of work on this. So tomorrow what we're going to do is continue refactoring down and organizing the code a little bit. And as well, I want to add in an additional statistic for the net revenue. So in our income information statistic, we have an annual gross revenue, which will compute the gross revenue, or so just the total number of sales combined across every year in our database. And I want to then cross-reference that against our gross annual expenses, take the difference and report out a net income based on that information, so we can take this one step further. And then we'll go ahead and continue adding in some more additional statistics as we can, and everything. So thank you guys so much for joining me tonight. I really appreciate you guys stopping in. Please leave a thumbs up and a subscribe if you guys enjoy hanging out with me. I stream every single day around 7 p.m. PST for good 2 hours. Today was 3 hours and 45 minutes. I'll sign it off here, guys. I'll talk to you later. See you tomorrow at 7 p.m. Bye, guys.